So this example has us trying to find the EMF for the battery shown, where we know all 6 resistances as well as the current far out in the 6th resistor. Okay, so we have to do a little bit of deduction, working our way backwards from what we know in order to come up with the total voltage that the battery supplies. So I'm going to write I6 is specified. I'm going to write I5 going across resistor 5, I4, I'll say going down. Again, this is a random guess as to the direction. I'll say I did it again. Darn it. I2, and then I1. Okay. All right, so let's start with what we know. We know the value for I6, which is the current through resistor 6, because R5 here is in series with R6, right? And that's the same leg of that circuit loop. The current I5 is the same as I6, okay? The voltage drops will not be the same because they have different resistances, but the current value will be the same. Okay, so we can make a note, I5 equals I6. So over here, let's make a table for all of these values, resistances, the voltage, and then the current. All right, so currents 5 and 6, we know because it's specified to be 1.4 amps. And they're the same. All right. The voltages, well, they won't be the same, but we can use Ohm's law to calculate that. V equals IR, so it's just that. Current is 1.4 times the resistance value of R5 was 8. And so this should be 9.6 volts. And V6 is 1.4 times 4. And so this should be 5.6. Okay, so we have 9.6 for 5, 5.6 for 6. Okay, and so now that we know both of those, we know everything for 5 and 6, we're working our way backwards now. Let's start taking a look at R2 and R4. At the node specified at the top there, Kirchoff's node rule says that I2 is going in, and that has to equal the currents going out, which is I4 plus I5. We need a way to find either I2 or I4. Okay, we don't know the voltage for, we don't know the current for yet. However, the voltage for parallel segments of the circuit, for instance, that one and that one, are the same. Right? Voltages for circuits or for circuit paths in parallel is the same. So we need to find the voltage on that outer circuit path through resistors 5 and 6. So the best way to do that is to find the equivalent resistance. So R56 is simply the resistances added up, which is 8 plus 4, which is 12 ohms. Okay. Now we know the current, well, that's still 1.4 amps. So now we can find the voltage, I'll say, I don't know, V56 is the current, I5, you can also put I6, it's the same thing, times that equivalent resistance. So that's 1.4 times 12. And this is equal to, I can't quite do that in my head. I should be able to, but I can't. That is 16.8 volts. And so that's the voltage across this segment, but it's also the voltage across this segment, which is the same as V4, so 16.8 volts. Okay, one more down. So what's that current then? I4. Now we have two of those three values. I4 is V, I'll say 4. That's the same as V56 divided by the resistance of 4. And this is that 16.8 divided by resistor 4 of 16. And this should be 1.05 current, which is amps. So 1.05. Okay, we're slowly working our way back, right? We found the voltage, we found the currents for resistances 4, 5, and 6. We're halfway there almost. Okay. Now we should take time to rewrite this a little bit, right? Let me redraw this circuit on the next page. So, battery, R1, R3, R2, R4, and then R5, 6. Okay. So again, our currents, to repeat, that's I1, down is I3, across this way, I2, down this way is I4. And I guess you can just write over here as I5. All right. What do we need? We need, for resistor 3, let's skip to resistor 2 because that's kind of next in line. So, what's the current in resistor 2? Well, now we can use the node rule, right? We have what we wrote here. Remember, I2 equals I4 plus I5. Well, we have both 4 and 5. So therefore, is I4 plus I5. Therefore, 1.05 plus 1.4. Thus, the current through resistor 2 is 2.45 amps. Now we can write that here, 2.45. Now we know the current, we have the resistance value, we can find the voltage through 2. So V2 is I2 times R2, which is then that 2.45 value times R2, which is 2 ohms, and this is our 4.9 volts. All right, we're getting there. And so now we know the voltage across R2, and we know the voltage across R4. We want to find the voltage across R3. But notice we have a loop here. We have a closed Kirchoff loop. So let's use the loop rule for that middle section. So let me start, let me start down here, okay, at that point. And I'll go clockwise. So starting from there, we start at some unknown value, right? I'll actually start it at 0. Going up, we're going in the opposite direction that we normally would, or that current is pointing. So instead of a voltage drop, it's a voltage increase. So plus I3, R3. Then we're moving through R2, and that is in the direction of I2. So now it's a drop. And then moving down through R4, same thing, voltage drop, I4 times R4. Okay, and then we're back to that dot. Well, we don't know the current 3 now. We don't know the value for I3, But can we know the value for that whole term? This whole term of the voltage 3 maybe? Let's rewrite that. V3 minus V2 minus V4. We know V2 and V4. We've already found those. V2 is 4.9, V4 is 16.8. So V3 is simply the sum of those, which is 21.7. Right? 21.7. And now we can find the current I3 It's that 21.7 divided by the value of R3, which is 2, and this is 10.85 amps. All right, almost there. Last one. We need to do another node rule. Now we have I1 going in, and that's equal to I3 going out plus I2. All right, so do we have both of those currents? Yes, we do. 2 and 3, 2.45 plus 10.85. That gives us, oh boy, 13.3 amps. And now we can get the voltage again. It's that 13.3 times the value R1, which is 2, I'm pretty sure. 2, yep. Which is 26.6 volts. Right? And now we simply add up those values and see what we get. So add up the voltages. We should get a whopping 48.3 volts. Should get 48.3 volts. Okay. Oh, I'm sorry. I'm not adding up all of those. That should be... Let me take that back. I'm only adding up the voltages for 1 and 3. There we go. Only adding up the voltages for 1 and 3. So in other words, the EMF equals V1 plus V3. Again, Kirchoff's loop rule. And that is equal to 26.6 plus 21.7. There we go. And that is our answer, 48.3 volts. All right. So this question was all about deduction, right, of what we didn't know, using what we did know. We started out way on the right side with the current 6 through resistor 6 and having to, well, figure out the voltages or currents, keeping in mind Kirchoff's node rule and loop rule along the way. So there we go. Thanks for watching.